How does a four-stroke petrol engine work? A four-stroke petrol engine, also known as an autocycle engine, is a type of internal combustion engine that uses four distinct phases: intake, compression, combustion, and exhaust to complete one power cycle. This process occurs over two full revolutions of the engine's crankshaft, or 720 degrees, creating a sequence that enables efficient fuel combustion and the generation of power. Here, I'll explain each phase in detailed paragraphs, exploring the technical workings and significance of each stroke in this engine type. 1. Intake stroke. The intake stroke is the first phase of the cycle. It begins with the piston moving downward inside the cylinder, creating a vacuum effect that draws a mixture of air and fuel into the combustion chamber. As the intake valve opens, the air-fuel mixture enters the chamber. The downward motion of the piston allows the cylinder to be filled with this mixture, and this action is crucial because it initiates the combustion process. The intake valve stays open for this entire stroke, while the exhaust valve remains closed, sealing the chamber from any release of gases. The purpose of this intake phase is to prepare the cylinder with a balanced air-fuel mixture, ensuring that there's enough fuel to ignite and create energy. The intake stroke completes as the piston reaches the bottom of its motion, also known as bottom dead center, BDC. 2. Compression stroke. In the second phase, the compression stroke, both the intake and exhaust valves are closed to trap the air-fuel mixture inside the combustion chamber. The piston moves upward from BDC to the top of the cylinder, called top dead center, TDC, compressing the air-fuel mixture into a much smaller space. This compression process is essential for two reasons: it increases the pressure within the chamber, and it raises the temperature of the mixture, making it easier to ignite. Compressing the air-fuel mixture allows the engine to generate a more powerful explosion during combustion. A high compression ratio is usually beneficial because it enhances efficiency and power, though it also requires the fuel to be of a higher octane to prevent pre-ignition or knocking, which can damage the engine. The compression stroke sets the stage for the power stroke by concentrating potential energy in the tightly packed mixture. 3. Power stroke, combustion stroke. The power stroke is the main energy-producing phase of the cycle. As the piston reaches TDC, a spark plug ignites the highly compressed air-fuel mixture, causing a rapid combustion, or explosion. This explosion forces the piston downward again, creating the power that drives the crankshaft. This is the only stroke that actually generates power to turn the wheels and propel the vehicle. The rapid expansion of gases from the combustion exerts a force on the piston, which transfers energy to the crankshaft and ultimately to the drivetrain of the vehicle. The power stroke is crucial because it's where the stored chemical energy in the fuel is converted into mechanical energy. The exhaust valve remains closed during this stroke to ensure no gases escape and that all the energy is directed toward moving the piston downward. Once the piston reaches BDC at the end of the power stroke, it is ready for the final phase of the cycle. 4. Exhaust stroke. The final stroke in the cycle is the exhaust stroke, which expels the burnt gases from the cylinder to make room for a fresh charge of air-fuel mixture. As the piston begins moving upward from BDC again, the exhaust valve opens, allowing the spent gases to escape through the exhaust port. The upward motion of the piston forces these gases out, clearing the cylinder. This phase is essential for maintaining engine efficiency and ensuring that the next intake stroke draws in only a fresh air-fuel mixture rather than a mixture of burnt and fresh gases. Once the piston reaches TDC again, the exhaust valve closes, and the intake valve is ready to open for the next cycle. This exhaust stroke completes the cycle and prepares the engine for the subsequent intake stroke, thereby repeating the four-stroke process. In summary, the four-stroke petrol engine cycle ensures efficient combustion by regulating the intake, compression, combustion, and exhaust of the air-fuel mixture in a precise sequence. Each stroke plays a crucial role in converting fuel into usable power, and the smooth operation of these strokes is what makes the four-stroke engine a reliable choice for most gasoline-powered vehicles.